So one of the main ones that you're going to have to understand how to do is to find the greatest common factor of two monomials. So when I go to factor these two and find the GCF, what is the first thing that I have to do? In case I'm not able to find the greatest common factor, what is the foolproof way to make sure I can do it?
By factoring it.
Okay, and what do I get?
You get 3. Well, for the first one, I got 3 times 5.
So as I do the prime factors, I notice that they have a 5 in common, they have a 3 in common, so 5 times 3 is 15, and they have 2 x's in common. So the GCF is 15x squared.
Oh, yes.
Let me throw in something. What if one of these was negative? What if one of the two monomials was negative? What would be the additional factor of that? Negative 1. Good. Now, what if I made both of them negative? Then they would have negative 15, exactly. So then the negative 1 would have been an additional factor, which when I integrated that in there would have made it negative 15x squared. So remember, this is different than the study guide. I changed both of them to be negative so that you guys remember that if both of them are negative, they have a negative factor in common. On the study guide, just to remind you, there was no negative. The original one from the study guide didn't have a negative 1. I just threw that in there to remind you that if it was a negative, you have to factor out negative 1 as well. It's like 1. Okay, so number 4 says the area of a square, so I'm going to highlight square because that's a key word, in square feet is represented by 625z squared minus 150z plus 9. Ooh, that's huge. Find an expression for the perimeter and then find the perimeter when z is 15. So I am picturing a square of which the area, that means the space on the inside, is 625z squared minus 150z plus 9. What do I know about the fact that the area of a square is given in relation to the sides of a square? If I have a square, even though it's a crazy looking expression up there, a square by definition has all equal sides. So if the area of that square was this crazy funky expression, okay, then I know that the two sides have to be the same. How do I represent when some number is multiplied by itself? A square exponent, power of 2. So I know that it is something squared, correct? Or if I wanted to write it out, it's two things that multiplied to give me that 625z squared thing. What is it that I am being asked to do if the area is that expression and they want, first of all, what is the first thing that I have to do?
Wait, I think I know stuff.
So they're asking to factor the quadratic trinomial so that I know what the two parentheses are, because the two parentheses represent the length of the sides. Yes, to factor this quadratic trinomial, like you said, you could do product of AC sum of B. But what problem am I going to come across?
Huge numbers.
Humongous numbers. So I could try to GCF something out, or hopefully I can recognize that this is a special case.
Yeah.
How can I tell that this is a special case?
If the like the 6 to 5 and then 9 are able to be
Square.
Yeah, if they are perfect squares, if you're able to square root them.
25.
Then everything can be squared.
And the square root of 625 is 25,
And 9 is
and the
3.
square root of 9 is 3, and my sign in between has to be
The first line, so it's negative.
negative because of the fact that they add to a negative and multiply to a positive.
Oh, on the video. It's
So
the first sign.
in reality, this is basically what the two sides are.
What happens?
And then you do the
The 150 is representative of the outer and inner terms being added together, correct?
Yeah.
So my first term is the 25z times the 25z. That gave me 625z squared. My last term is the 3 times negative 3. And the middle term is the outer terms, which is negative 75z, and the inner terms, which is also negative 75z, which together add up to that negative 150. So the fact that I know that this is a perfect square trinomial made it so that I don't have to worry about multiplying the 625 and the 9 and getting humongous numbers. That's the reason why it's important to always ask yourself, is there a GCF? And then the next step, is it a special case? Because it'll save you probably about a whole page of work.
Would you get the same answer? If you
Absolutely. If you did product of AC sum of B, you would still get the same answer if you got the right factors to expand the middle term. So now that I know that the expression, the two sides basically are 25z minus 3, they want to know the expression for the perimeter. So if the side's 25z minus 3, what do I know about every side?
The same.
It's the same. So that means I have how many of these?
4.
4. How can I write something like I have 4 of these?
By putting in parentheses and make exponent 4.
What does an exponent of 4? In this case, I have 4 sets of 25z minus 3's, which then I can use the distributive property, and I get 100z minus 12.
Wait, why do you have 4 of them?
Perimeter when z is 15. So if I know that the expression for perimeter is 100z minus 12, what is the value of that if z equals 15?
0.12.
15, that means I'm plugging z, 15, into that expression, and it's really 100 times 15 minus 12. Well, 100 times 15 is 1500, minus 12 is
1,488.
1488. The next type of question that you are going to make sure that you understand is going to be like number 5, where it asks you to factor this. They're not going to tell you what to do. You need to know, okay, I'm factoring. It means I'm breaking it down into multiplication problems, which means I have to think of my steps to factoring. Is it in standard form?
Yes.
Is there a GCF?
Yes.
Oh, why, yes it is. What is the GCF?
4.
4y. When I factor out the GCF, what is left inside?
4y plus 3.
4y plus 3. I check to see that I'm done by going back and asking myself, is there another GCF of the parentheses?
No.
So that is my completed factored form. Just because I want to make sure that you understand everything. What if I had a negative 16y squared plus 12y? What would I have to have factored out?
You would have to have like it'd be like a negative 4y.
Yes.
And then like another.
Correct. You would have had to.
Positive and then
You would have had to factor out a negative 4y, and then what's left is
positive and then.
positive 4y and negative 3, because together the negative and the negative gave you the positive. Excellent. I'm going to skip to number 7.
Oh, wait. What about number 6?
Factor. What is my very first step?
Standard form.
Is it in standard form?
Yes.
Yes. Exponent of 6, 5, 4, 3. It's descending, so it's good. Step 2. GCF it. Well, when I look at this, what do I recognize? There's 4 terms.
So you group
So immediately go straight to grouping, and that's where you're going to do the GCF. So there's 4 terms, and then you say group my front 2, group my back 2, and now GCF each parentheses. What can I factor out of the first binomial? 4x to the 5. What is left?
x minus 5 in the parentheses.
Excellent. Move to the next parentheses.
12.
Positive 12
And x3.
x to the third. What's left?
X minus 5x. X minus 5.
Cool. So, FYI, at this point, you should recognize that your job is to try to get 2 common parentheses. So, when you go to the next one, that should be the same parentheses. So, check to see that. That should just be sort of like a check in between the work.
Yeah.
Now, I look to see what can I factor out of that expression. What do they all have in common?
X minus 5.
The parentheses x minus 5. That is factored out, and what is left?
4x5 plus 12x3.
Am I done?
No.
No, you're not. How do you know?
Because 4 and 12.
Yeah, 4 and 12 can be factored out even more,
Oh wait.
right? You always need to look inside your parentheses to make sure that it is factored all the way. Kind of like when you have a fraction. If I say 25 over 50, simplify that. If you ended up going all the way down to 2 over 10, or sorry, 2 over 4, that's not simplified all the way. You got to simplify each parentheses even more. So yes, what is it that I factor out of the first parentheses?
4x.
Excellent. 4x to the 3. When I take that out, what's left?
X2 plus 3.
Plus 3.
Fantastic. Don't forget this other parentheses dude, right? Excellent.
Yay.
Am I done?
Yes.
Yes, you are. Wait, who said no?
Wait, what do you?
Remember, these 3 items, that means that these 3 numbers multiplied together are going to give you your original. So how can I make sure I'm correct?
You can unfoil it.
You could refoil it,
Oh,
right? You could foil this because it's a binomial, or you can distribute and then you get another binomial and then you foil it with that one, and then you check your work and make sure it's correct. That might take an additional minute to do, but it'll guarantee you know that it's correct or not. Okay, so redistribute and you get 12x to the 5 plus 12x, not 12, 4x to the 5 plus 12x to the 3rd. That binomial is going to be multiplied to the x minus 5, and because it is a 2 binomials, I'm going to foil. First times first is 4x to the 6. Outer times outer is negative 20x to the 5th. My inner 2 terms multiply to positive 12x to the 4. And my last terms, this is where I messed up before, is negative 60x to the 3rd, which, if I look at the original question, I could tell that it's the same, so that means that I factored it out correctly to begin with. 12x to the 2.
What's your thing?
Number 10 and number 11. It asks me to factor, so I know I'm going to put it in standard form, which it is. GCF it.
No.
Not necessarily. You have to always check for GCF. Can I factor this GCF?
Yeah.
Is there a GCF?
Oh, no.
No. So what do I do?
Multiply.
So I look at it and I say, oh, there's no A, correct? Yay, A is 1. This is an easy one. I can work the shortcut. The shortcut is, because my first term times my first term gave me x squared, I know that my first 2 terms are x. Then I can just look at the back guy and say, I need to multiply to negative 70, but add, because that's your outer and inners added, add to negative 3. What 2 numbers multiply to negative 70 and add to negative 3? 7 and 10, and it's negative 3, so negative 10 and positive 7. Now, I could just go plus 7 minus 10. Much easier.
Minus 10 plus
However, let's do the ACB for number 11 just to show you. This understanding that when A is 1, so the coefficient is 1, understanding that when you have that, it makes it really easy to just break it down this way is really important because it conserves time. However, let's say that you are like I was, and when you take a test, you get a little overwhelmed and your brain kind of doesn't think too much properly. If that happens and you have a problem that is supposed to be easy for you to do, it's okay if you still do ACB. ACB, it's just a method of saying to yourself, I am going to expand out the middle term. And the expansion of the middle term is finding the product of AC that sums to B. Well, A is 1. 1 times 22, A times C is 22. So I'm looking for something that multiplies to 22 that adds to negative 23?
Negative 22 times negative
22 and 1.
Negative 22 and negative 1. They multiply to positive 22 and they add to negative 23. Those numbers are meant to expand out the middle term. Remember, you have to put the variable in there. If you made it this way, and you rewrote the others, and you did your grouping, because there's 4 terms, group, I could factor out of the first one an x. I'm left with x minus 22. The next parentheses, I could take out negative 1, and I'm left with x minus 22. And then you realize that you have the x minus 22 as one parentheses and the x minus 1 as the other. If you refoiled it, you would get the same answer. Let's say that you did it this way. That's still correct. The shortcut way, if I would have done this, if I would have recognized that this was an easy question to do because there's no a, or a is just 1, I would have said to myself, oh, it's 2 parentheses, x and x. What multiplies to 22 and adds to negative 23? Oh, negative 22 and negative 1. And you would have just gone straight into writing the answer without all that extra work. This is the only reason to why it's important to know shortcuts, because it saves you time. That is much faster than this method, but this method will always work. Let's look at number 12. Number 12 says to factor. And what I need to do is make sure that I put it in standard form, which it is. I factor out the GCF. What can I GCF? 3 what? 3x2. What's left? x2 minus 5x plus 4. I'm not done yet, because now where do my eyes go to? Look at it, and I say, oh, I see this is a quadratic trinomial, which means I'm going to unfoil it. And it's an easy one with no coefficient. So I rewrite the 3x2 because it is still a factor. Then I take this parentheses and I break it down into the 2 binomials that it represents. I know x squared is x times x, and the the products of 4 that add to 5 are 1 and 4. They multiply to a positive and add to a negative. So that means it's negative 1 and negative 4. Now I'm factored.
And what happened to the negative 5?
You check my work, and you should always check your work. If I wanted to check my work, I would refoil this. I would get x squared minus 4x minus 1x plus 4. All of that is still multiplied by 3x to the 2. Correct? This can be simplified to x squared minus 5x plus 4, which is, again, multiplied by 3x2. When you redistribute that, it would give you 3x to the 4 minus 15x to the 3 plus 12x to the 2, which is the same that you started with, so you know that this is correct. Your answer is the factored form.
But there isn't the
So the answer to this entire thing for number 12, the answer would have been the factored out 3x squared and then the 2 parentheses of x minus 1 times x minus 4. That's your answer. Is like number 13. Let's look at number 13. Asks me to factor. I ask myself the steps. Is it in standard form? Yes, it is. Is there a GCF? No, there's not. Is it a special case? No, because the square root of 11 is not a perfect square. So then it's product of AC, sum of B. How come I have to do ACB with this one and not with the other ones? Because you have a coefficient of A. Yes.
Because what?
Because the A is 2. So I am looking for numbers that multiply to 22, because 2 times 11 is 22, positive, that add to positive 23.
22 and 1.
Positive 22 and positive 1. Now remember that these are the expansion of the middle term. Plus 22x plus 1x. So 22 and 1 go in the middle. Then you carry down the other two guys, and now what you have is a 4-term polynomial, which means you need to group, factor. When I group the front two and I group the back two, what can I factor out of the first parentheses? 2x. What is left?
X.
Plus 11.
Now, don't forget, this one here, you have to also find a GCF.
1.
Positive 1, and I'm left with x plus 11.
And then,
Correct.
and then
We have the common x plus 11, which I write down, and then you're right, you're left with the second binomial of 2x plus 1. Now, if I refoiled it, which you should do because you'll have time to do it, I would say first times first is 2x squared. The outer terms is positive 22x. Inner term is positive 1x. Last times last is positive 11. And the middle terms combine to 23x. So that means that as I look at my work and I refoiled it, it gives me the same. So I know that I factored it out correctly. So that means that my answer is 2x plus 1 multiplied by x plus 11. This is the factored form of the original. So when I look at this one, I say, is it in standard form? Yes, it is. Is there a GCF? No, there's not. Is it a special case? No. So what's the next method? ACB. I always like the little chart because it kind of helps me. A is 5, C is -2, and B is -3. What multiplies to -10 that adds to -3?
-5 plus 2.
-5 and positive 2. Excellent. These are the expansion of the middle term. So you rewrite the first term. Now it's -5a and positive 2a, and then minus 2. It doesn't matter the order of the -5 and the 2, as long as the negative is with the 5 in this example. From this point, I know that I have 4 terms, and so I'm supposed to group the front two, group the back two, and factor each independently. What can I factor out of the first parentheses?
5A.
5a. What is left? A minus
A.
1.
Oh, that's
Because if you think about it, when you divide by 5a, if you factored out the entire 5a, it means it must have been left with 1, so that when you remultiply it, you get -5a.
Oh, it's the same thing for that.
And the same thing with the next one. I'm going to factor out a positive 2, which means you're going to divide each by 2, and you're left with a minus 1.
Is that a shortcut?
What, the division part? It just is a way to make sure that you don't overlook it. Now, my main parentheses is a minus 1, and the other one is 5a plus 2. And again, order doesn't matter in this case.
Commutative property.
Commutative property, very nice. And if you were to redistribute, you refoil, you would get first times first is 5a squared. The outer two terms multiply to -5a. The inner two terms multiply to positive 2a. The last two terms multiply to -2. And when you combine the middle terms, you get 5a squared minus 3a minus 2. So you know that you did it correctly. We'll go back to the other ones for sure, but we're going to do these two real quickly because these are the ones that are like on the next questions on the test. You will be asked to determine whether it is a perfect square trinomial or not. Now, when I look at this question here, so when I look at this one here, in order for me to be able to check to see if it's a perfect square, that's the special case, what is it that I have to do? So you guys do these two real quick while I... How do I check to see if it's a perfect square trinomial?
Square root.
Oh.
What do I do?
Square
And C, yes. So if I took the square root of n squared, what do I get?
1.
N.
Oh, N.
N, because the N squared.
And the square root of 100? 10. So what would this be if it was a perfect square trinomial?
n plus 10.
N plus 10 squared. So I'm going to check to see if it works. Who am I looking to make sure that it works?
The middle.
The middle term, because, yeah, it's easy to see that n squared gave me n times n, and 100 is 10 times 10. But remember that sometimes the middle term, which is representative of what two terms being added?
A and C. Oh, no.
The out.
The outer and inner, right? So we want to make sure they add up to 20. So my outer is what?
10.
And middle? What does that add to?
20.
So we know that it's n squared, because we got that. First times first.
Oh, 20.
100, and the 20n is the same. So is this a perfect square?
Yes.
Yes. Excellent.
So you just FOIL to check it?
Exactly. Awesome. Okay. You're supposed to take the square root of x squared and you get x. You're supposed to take the square root of a negative number, which is not possible. It's imaginary. So this is not a perfect square trinomial.
I literally.
So if I was to factor this and I thought that x minus 3 was the answer, just to show you, and I was to refoil to check my work, I would get first times first is x squared. I would get the outer of negative 3x. I would get the inner of negative 3x. And then the last negative 3 times negative 3 would give me positive 9. So that wouldn't have worked. And if I would have tried a positive, it would have given me a positive in the middle term. So that wouldn't have worked. And if I would have tried letter C, that would have canceled out the middle term. And so that would have given me x squared minus 9, which wouldn't have worked.
So basically just try.
Number 19. Number 19 says to factor, but hopefully your brain is triggering that this is a...
Binomial.
It is a binomial, and it's
Easy.
a perfect square. So you look at it and you say, is it in standard form? Yes. Can I GCF it? No. Is it a special case? Why, yes. 3p, and the square root of 225
But it's
is,
negative.
that's right, but it's no middle term. So what is the square root of 225?
15.
15.
Wait, but
That means that
You can't square
one of them is positive and one of them is negative, because when you multiply positive 15 times negative 15, it gives you negative 225. And when you FOIL it out even more and you do 3p times 3p, it's 9p squared. Outer is negative 45p. Inner is positive 45p. And the last term is negative 225. The middle term cancels out. And when I cancel out the middle term, I am left with 9p squared minus 25. However, I want to see if you guys recognize an additional problem that I did.
can't you just divide that? Can't you just GCF it because it's
That's
3?
exactly right. So as I went to complete this problem, I purposefully continued to solve it with not going to the steps of GCFing. At that point, you hopefully will recognize that each of those parentheses can get a 3 factored out even more. So I'm going to show you the long way of fixing that. This parentheses, you would take the 3 out and you would be left with p plus 5. This parentheses, you would take the 3 out and you would be left with p minus 5. And then because these 3's are being multiplied, it's really 9 times p plus 5 and p minus 5. That's the long way. In order to make sure you don't come across this problem, you need to follow the steps. And the steps are just guided practice. It's just ways for you to be guided to the answer. Is there a GCF? Yeah. 9 is the GCF.
Oh, no.
If I factor 9 out, I'm left with p squared minus 25. Which then, I can see that this is the difference of perfect squares that I didn't even need to do a calculator for. And you get the same exact answer.
That's what I got, but I did with...
Has anybody seen a pair of arrows?
If you can do all of the questions that we just went over, you are going to do great on the test, because that is what it's all about. So let's go back and look at number 15 just to make sure we understand that one too. When I look at this question, I go through my steps in my head. The steps in my head include, is it in standard form?
Yes.
No.
It is in standard form because it's got the coefficient. That doesn't mean it's not in standard form. Standard form says descending order of exponents. Step 2, can I GCF it? Yes, I can.
Oh.
Oh, and by the way, you have a
negative.
by the way, you have a leading coefficient which is negative, which means when you GCF it, you got to factor out a negative. What number factors out of all of these digits?
2.
Negative 2. How about variables? Anybody else can come out?
X.
Negative 2x. When you go to see what's left in the parentheses, one of the things you could do is divide everything by that GCF that you just took out so that you could visually see how to do it. Because sometimes you can't picture it in your head, but if you see it on paper, it's so much easier. So I took out the negative 2x. That means that negative 4x to the 3 divided by negative 2x is
2x squared.
positive 2x squared. Negative 14x2 divided by negative 2x is positive 7x. 8x divided by negative 2 is, negative 2x is negative 4. Am I done? Yeah, 8 divided by negative 2. I am not done because I have a quadratic trinomial that must be unfoiled, right? ACB, dudes, ACB. So I'm going to ask myself, all right, I'm going to factor out this parentheses and I'm going to look for the numbers that multiply to negative 8 that add to positive 7.
It'd be 8 and negative 1.
It would be 8 and negative 1. Remember that these are the expansion of the middle term.
Wait, when's the middle?
I rewrite the GCF that I took out because it's still there. Then I am going to expand out the middle term. The 2x squared remains. 7x is really plus 8x and minus 1x. And I rewrite the minus 4. Within that, I factor out by grouping the 4-termed expression.
Do I have to put 1x?
You factor out,
Yeah.
you factor out of the first one.
Or can I just put X next to that?
From this, I'm going to factor out 2x, and I'm left with
X plus 8.
x plus 4. From the second one, the second parentheses, I'm going to factor out negative 1, and I'm going to be left with x plus 4. But who do I have to remember not to forget?
Outside one.
The negative 2x. Okay, there's a Shakira song, I can't remember to forget you. Okay? You can't remember, you've got to remember to not forget negative 2x.
Can you combine?
Oh, no.
Then we look at this and we see, yeah, look, we have a common x plus 4. So we're going to write that x plus 4 on the outside. The 2x minus 1 is still there.
And then negative.
And then I can't remember to forget you. Well, I can't forget you, negative 2x.
Are you gonna?
Let's look at number 16. And this says, it says just a factor. So I have to remember what factoring means. I'm breaking it down to the numbers that multiply to themselves. I look at it and it's a quadratic trinomial and I go, oh, I'm going to break this down into 2 parentheses. So I have to think of my steps. Step 1, is it in standard form?
Yes.
Is there a GCF?
No.
I have to unfoil. Is it a special case?
No.
Product of AC, sum of B.
Yes.
So
Negative 56.
I have A, I have B, I have C.
We'll do 8 times 7, which gives you 56. And then you have to find...
So remember, it's negative 56 because
Negative
it's
56, my bad. And then you need to get something times 56, which is equals to negative 10.
excellent. So let's think of this. Think of all the factors of 56. 1 and 56 doesn't work. 2 and
14 and 4.
28. Oh yeah, 4 and 14.
Negative 14.
Excellent. So it's 4 and 14, but they have to add to a negative, so the bigger one's negative. These are the expansion of the middle term. Remember that. Every time you do ACB, it's the expansion of the middle term. So I'm going to expand this out to plus 4x and minus 14x. I'm going to bring down the negative 7 and the 8x squared. I look at it and I see 4 terms. Yay! I'm going to group the front 2, group the back 2. What can I factor out of 8x squared and 4x? 4x.
Wait, doesn't matter what way.
Uh-oh, spaghettios.
When I factor out the 4x, I'm left with 2x plus
1.
1. Please don't forget, when you factor something out completely, you put 1 in its place. When I'm looking at negative 14x and negative 7, what can I factor out of that?
7.
Negative 7, and you're left with 2x.
Plus 1.
Fantastic.
I didn't get
Oh, I did it.
The parentheses is 2x plus 1 and 4x minus 7.
These ones are my favorite.
Now, that's awesome. I'm going to show you guys something that was just brought to my attention.
I did not get the same answer.
What happens if in the process of solving this, instead of putting plus 4x and minus 14x in the middle, you swap the order? So I know Caleb did it this way. Minus 14x plus 4x minus 7. It still would have worked out correctly, the same if you worked it out correctly. I group the front 2 and group the back 2. When I factor them out from the bottom one, I would get 2x that I factor out, and I'm left with 4x minus 7. When I look at this parentheses, I have to factor something out, so I factor 1 if there's no GCF. And you're left with 4x minus 7.
Whoa. Whoa.
You notice that your parentheses is now 4x minus 7. And what's left is 2x plus 1. You get the same exact answer. So the order of the 4 and the 14 negative don't matter. But what does matter is that if the negative is in the wrong spot, then you wouldn't get the right answer.
Oh, that's
I'm asked to factor this. I ask myself, is it standard form? Yes. Can I GCF it? No. Is it a special case? Yes, it is.
Wow.
It is a special case. The square root of x squared is x. The square root of 36 is 6. There's no middle term, right? There's no bx. That means that your outer and your inner, when you added it, canceled out. So that means this is the difference of perfect squares, which is x plus 6 times x minus 6. Boom. Remember, you can always check your work by refoiling. X squared minus 6x plus 6x minus 36. The canceled of the middle terms gives you x squared minus 36. Step 1. Is it in standard form?
Yes.
Is there a GCF?
No.
Yes, there is. 2. What am I left with? 9x squared minus 25. What is that in the middle called? Difference of perfect squares. It's a special case. It's a special case. What does that 9x squared minus 25 break down to?
3x.
Plus 5 and 3x minus 5. But don't forget the 2.
Oh, because you can. Okay.
Wait, so
What I would recommend that you do to make sure that you have factored it out all the way is look at your remaining parentheses, and if there is exponents in it, ask yourself if you can factor it further. So I knew at this stage of the game that I could factor it further for 2 reasons. First of all, because I saw there was an exponent of 2. Second of all, because I looked at it and I realized that these are special cases. Look at that, it's a group of 4. It's in standard form. Group, group, factor. What can I factor out of the first binomial?
3x squared.
Just x2.
Kidding.
Because 5 is not divisible by 3.
I was right.
And I can be left with 3x plus 5. What can I factor out of negative 12x and negative 20?
negative 4.
What am I left with? 3x plus 5. Now,
Oh my god.
notice that my parentheses are 3x plus 5. And then the other one is x squared minus 4. What does it look like?
A binomial.
I'm not done factoring.
Oh, no, you factor.
Because it's the power of 2, I realize, oh, this could break down. And then I realize that this is a special case. It's x plus 2 and x minus 2. And then you rewrite that 3x plus 5. So,
Wait, I'm confused.
when your highest exponent, if you are recognizing patterns, when your highest exponent is 3, it means that you have up to 3 different things that can multiply together.
So the answer would be x